welcome to Two Projects. In this video, we are going to explain the project and implementation of blockchain technology in combination with IPFS for crime evidence management system. Introduction. The project at hand addresses the crucial need for digitalizing crime evidence in the contemporary digital era, emphasizing the significance of maintaining the integrity of evidence throughout investigations. Tampering and unauthorized access pose serious threats to the reliability of evidence, prompting the exploration of innovative solutions. Traditional methods of evidence handling face inherent vulnerabilities, making them susceptible to manipulation and compromise. The lack of a robust traceability mechanism in the chain of evidence process raises the concerns about the authenticity of the information presented in court. Additionally, the manual and time consuming document review processes in traditional methods hinder the efficiency of investigations. These drawbacks necessitate a paradigm shift towards more secure and technologically advanced approaches. So, the project proposes the integration of blockchain technology to address the shortcomings of traditional methods. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. And blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And the project specifically utilizes the Ethereum blockchain for its robust smart contract functionality. Smart contracts are programmable contracts that execute predefined rules and conditions. In this project, smart contracts enhance the security and transparency of the chain of evidence process, enforcing rules related to evidence handling. The decentralized nature of Ethereum contributes to the overall security and reliability of the proposed system, ensuring a trustworthy and tamper resistant environment for crime evidence management. Objective of the project. So, as I mentioned earlier, the primary objective of the project is to create a secure blockchain system for digitizing crime evidence, employing cryptographic features to guarantee tamper proof records. And we aim to implement blockchain measures to maintain the integrity of sensitive data throughout investigations, establishing a robust and trustworthy chain of evidence. We aim to utilize Ethereum blockchain for immutable digital evidence. This ensures resistance to unauthorized alterations, leveraging Ethereum's capabilities to enhance the permanence, reliability, and authenticity of recorded information. And the objective also includes enabling decentralized, transparent transfer of digital evidence among parties without a central authority. The decentralized structure of blockchain allows multiple parties to securely exchange, access, and verify evidence, contributing to a trustworthy and efficient transfer process. Requirements needed to execute this project are software requirements. Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask Chrome extension. Backend languages used are Python, JavaScript, and Solidity. Framework used is Flask. Frontend languages used are HTML, CSS, JS, and Bootstrap 4. Hardware requirements needed are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. To execute the project, we have designed few modules. So first we'll discuss the lab modules. The first one is lab in charge registration. In this module, lab in charge registers with necessary details to access the system, providing credentials for secure login. The second module is lab in charge login. Here, lab in charge logs in using registered credentials, gaining access to the system's functionalities and features. The third module is add evidence. After logging in, lab in charge adds evidence by entering evidence number, description, and uploading corresponding files, contributing to the central database. Now we'll discuss the hospital modules. The first one is hospital registration. Here, hospitals register to use the system, providing essential details for authentication and access. The next module is hospital login. After registration, authorized hospital personnel log into the system using registered credentials, accessing relevant functionalities. The next module is check evidence and validate. In this module, hospitals verify and validate evidence related to cases they are involved in, ensuring accuracy and contributing insights through validation. The next one is add review. Here, hospitals contribute by adding reviews or additional information related to evidence, enhancing the overall case information. Now we'll see the police modules. The first one is police registration. So, police personnel register for access, providing necessary details to authenticate their identity. The next module is police login. Here, authenticated police personnel log into the system, gaining access to functionalities tailored to their role. The next module is check evidence and submit report. In this module, police personnel review evidence related to ongoing investigations, submitting detailed reports for case progression. Now we'll discuss the court modules. The first one is court registration. Here, courts register for access, providing details for authentication and access control. The next module is court login. After registering, authorized court personnel login, accessing functionalities relevant to their role in the legal proceedings. The last module is check evidence. Here, courts review and check evidence related to cases, facilitating informed decisions during legal proceedings. Blockchain integration. So, we have utilized blockchain's cryptographic features for secure digitization of crime evidence. Each block in the blockchain is linked with a unique hash code. The hash code verification process ensures the integrity of the data. Any modification to block data results in a different hash code, triggering security alarms and maintaining the tamper proof nature of digital records. We have implemented blockchain measures to securely maintain the chronological order and unaltered sequence of evidence as it moves through intermediaries. This ensures the establishment of a robust and trustworthy chain of evidence in the investigation process. We have implemented blockchain to enable decentralized, transparent transfer of digital evidence among involved parties without relying on a central authority. Blockchain's decentralized structure facilitates secure exchange, access, and verification of evidence, contributing to a trustworthy and efficient transfer process. And we have leveraged Ethereum blockchain smart contract functionality for transparent and verifiable communication. Smart contracts define rules and protocols, enhancing communication without the need for third party involvement, thereby contributing to the overall security of the system. And we have used Ganache in this project. So, Ganache is a user friendly interface for monitoring Ethereum blockchain activities. It simplifies tracking of accounts, transactions, and smart contracts, making it accessible even for users without in depth blockchain expertise. Ganache offers detailed transaction information, including sender, receiver amounts, gas usage, and success status, aiding debugging and ensuring transaction accuracy. It also tracks smart contract deployments, confirming correct deployment and functionality. This transparency simplifies monitoring and verification processes. And Ganache lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, that is gas, was used. Ganache also enables data retrieval from stored blocks, allowing developers to access and analyze specific block information. And we have also used MetaMask in this project. So, MetaMask is both an Ethereum wallet and a browser extension. It simplifies cryptocurrency management and provides direct access to dApps, making interactions with blockchain applications easier. So, in this project, MetaMask ensures secure Ethereum transactions, promoting transparency by showing the deduction of ETH as fees. This transparency maintains accuracy and ensures confident, reliable financial interactions within the system. Execution of the project. To execute the project, first we need to open the code folder which contains the project source code files. So this is contracts folder in which I have Solidity files. They handle data structures, functions, and events with modifiers for validation. This is static folder. It consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is run.bat file to start the evidence management system, and this is run.bat file to start IPFS server. So IPFS is a decentralized file storage system for secure and distributed data sharing. Blockchain is effective for recording transactional data, but for large file storage, it integrates with IPFS. So now double click on it. So we can see the IPFS server has been started. Now minimize this. So before running the run.bat file, we have to host the Ganache server. For that, open Ganache. So we can see the server has been hosted. Now we'll get back to the code folder. Now double click on run.bat file. So the Flask framework will host the application locally at the default address, local host and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see lab, hospital, police and court. So first we'll register as lab in charge. Click on register link. So here we have to fill in all these details and click on add lab in charge button to register as lab in charge. So username would be lab. Give the password. Give the contact number. Give the email ID and the address. Now click on add lab in charge button. So here we can see lab in charge sign up task completed. So all these registration details will be stored in blockchain in a form of block. So if we see in Ganache, so we can see a block has been created in which all these registration details will be stored. So we can retrieve the data from here. Minimize this. Now we'll log in as lab in charge. Click on login link. Give the previously mentioned credentials, username and password and click on submit button. So we have logged in as lab in charge and here we can see add evidence and logout links. Click on add evidence link. So here lab in charge can add new evidences to the system. We have to fill in all these details. Evidence number would be 1. Evidence description is blood clot and we have to upload the evidence related documents or images here. Click on choose file button. So I'm uploading this one and click on open. Now click on submit button. So here we can see the evidence is saved to blockchain and we can also see the IPFS generated hash code of the image uploaded. So this hash code will also be saved to blockchain. Now click on logout. Now we'll register as hospital. Click on register link. Fill in all these details. Username would be Apollo. Give the password. Give the contact number. Give the email ID and the address. And click on add hospital button. So we can see hospital sign up task completed. So all these registration details and evidence details will be stored to blockchain. We can see the Ganache. So blocks are being created in which all these details will be stored. Minimize this and in MetaMask Chrome extension, we have to give the password here. So we can see I have a balance of 99.9714 ETH in my MetaMask wallet, which represents the deducted amount after recent transactions. So, in the context of a blockchain, transactions refers to the actions or operations that are recorded on the blockchain ledger. So, now we'll log in as hospital, give the credentials, username, and password of hospital, and click on submit button. So we have logged in as hospital, and here we can see check evidence and validate and logout links. Click on check evidence and validate link. So here hospitals can check the evidences added by the lab in charge. So here we can see a click here to submit feedback link. By clicking on this link, hospital can add their review or opinion about the evidence. So I'm clicking on it. So we have to add the review here. So I'm giving it as the blood marks belong to Suresh. Now click on submit button. So we can see evidence saved to blockchain. Now we'll register. Click on logout. Now we'll register as police. Click on register link. Fill in all these details. Username would be police. Give the password. Give the contact number. Give the email ID and the address. Now click on add police button. So we can see police sign up task completed. Now we'll log in as police. Click on login link. Give the previously mentioned credentials, username and password, and click on submit button. So we have logged in as police, and here we can see check evidence and submit report and logout links. Click on check evidence and submit report link. So here police can view the evidences added by the lab in charge and the hospital review. And here we can see a check here to submit feedback link. So by clicking on this link, police can add their analysis or report. So I'm clicking on it. So here we have to add the report. So I'm giving it as Suresh has been shot using a gun. Now click on submit button. So we can see evidence saved to blockchain. So we can see the blocks being created in the Ganache. Now click on police screen link. Click on check evidence and submit report link. So here we can see the action that is already submitted. Now click on logout. Now we'll register as court. Fill in all these details. Username would be court. Give the password. Give the contact number. Give the email ID and the address. Now click on add code button. So the registration is completed. Now we'll log in. Give the previously mentioned credentials, username and password, and click on submit button. So we have logged in as court, and here we can see check evidence and logout links. Click on check evidence link. So here court can review the evidences, hospital reviews, police investigations to make a final decision. So we can see evidence number, evidence description, hospital review, police review, and the image of the evidence. So now click on logout. So if we see in Ganache, all transaction details and registration details will be stored in the blockchain as blocks and can be retrieved from here. So we can see blocks are created. Now click on any block. So we can see block hash and transaction hash. Click on transaction hash. So here we can see sender address, to contract address, gas used, gas price, gas limit, and the transaction data. Minimize this, and in MetaMask, so we can see ETH balance remains unchanged after each block creation because the project's actions don't involve significant aid transfers. This is normal as not all operations lead to substantial balance changes. So, the conclusion here is the integration of blockchain technology significantly enhanced the security of crime evidence digitization. The cryptographic features and unique hash codes establish a robust defense against tampering, ensuring data integrity. This blockchain implementation ensured a trustworthy chain of evidence by maintaining the chronological order of digital evidence. This feature provides investigators with an unaltered and reliable sequence crucial for the integrity of investigative process. The adoption of blockchain facilitated decentralized, transparent transfer of digital evidence among involved parties. This not only enhances efficiency but also reduces reliance on a central authority, fostering a more agile and collaborative investigative environment. And the utilization of smart contracts on the Ethereum blockchain brought transparency to communication protocols. By defining rules and ensuring verifiable interactions, trust is established without the need for third party intermediaries, contributing to a more secure and streamlined system. And we have integrated IPFS for secure and distributed evidence file storage, enhancing security through content addressing and hash codes, ensuring a tamper resistant storage solution.
Project videos. Please visit True Project's YouTube channel and subscribe.